Hi everyone, we are the Vandenberg team, also known as switchBoss. I'm Andrew.
I'm Ryan.
I'm Matt. I'm Danny. All right, so Lefty came to us with the problem of his power grid being clunky and not useful for his team. So we actually went to the base and we saw the piece of plywood with all the LEDs on it. It's about the size of one of these whiteboards. It's pretty big and it's not very useful. The main problem being that it doesn't really show if a wire or a circuit is energized or not. And that's a big problem for him in terms of safety and his team. Also, it can't be edited. So we went there and there's a bunch of tape and Sharpie lines all over it, which isn't very useful if you ask me. So that was the problem. We came up with the solution of creating an interactive, easy to use computer display that reacted to all kinds of circuit problems, including switches, circuitry, and then we wanted to make sure that these components were interactive, so if we clicked on them, things would change and the circuit would respond correctly. So the stakeholders on the base, Lefty is our main client. He oversees a group of 6 civil and electrical engineers who will mainly be using the grid to complete its everyday power operations. Obviously, people stationed in Vandenberg need the power, so they're a big stakeholder in this. And then also, this kind of technology, this kind of grid use can be used in other civil applications such as water or sewage or things like that, road networks, trains, subways. Yeah, so there's that.
All right, and then obviously as we're making a power grid display, we're going to have to use some information about the power grid itself, which is sensitive information. So us 4 and John Oliver all signed non-disclosure agreements. But the problem with that is Lefty talked with his engineers and he didn't feel comfortable with us using GitHub or any of those like software-based to hold the data. And additionally, like for demo purposes for this class, even we couldn't be able to show the actual grid. So instead, what Lefty did is he made a mock-up grid over here on the side, and that grid has all the information, all the logical information that the normal power grid would have, without including some of the sensitive information on like what power is leading to what facilities and such. And additionally, using this grid, we would also be able to add features to edit the grid later. So we would design this mock-up grid on the right here, and then once we implement that, Lefty would be able to edit it as a user and be able to implement the actual grid. So thank you. And so yeah, this is the grid we have right now. It's very similar to what he gave us and all of that. And so here's part of the top middle part zoomed in here. So it's all Star Wars themed as well, which is a nice touch. But this isn't all too different from what you've seen like circuits classes and that sort of thing. So normally if switches are denoted by like a diagonal line and a little break, but here they're just 2 parallel lines. And so those are switches, and then circuit breakers are the squares here. And then we also have transformers to bring down the voltage from 70,000 volts down to 12,000. And so the idea is we have all the logic that a normal actual power grid has. So in a use case, if a circuit breaker went down, Lefty or one of his engineers would close both of these switches. Not shown on the grid is there's going to be a switch in parallel with these 3 components without they be able to close when the circuit breaker goes down, so that the facility would still receive power. They'd then open both of these switches, remove the same circuit breaker, put in a new one, and then reverse engineer that process. So that's kind of like a basic use case for if a circuit breaker went down.
So in collaboration with Lefty, we determined that his requirements for both him and his team of engineers fell into each of these 3 categories. So functionality, safety, and future-proofing are the 3 most important things that this tool has to have, and that will help him and his team use it in the most efficient and effective way in the future. So starting with functionality, this is just basically how the program works. Like pretty simple stuff, just like it shows the grid. You can edit it, you can modify stuff. It has to maintain correct circuit logic, of course, since it's a power grid, and power is electricity. And then the next one, safety. This is really important because the power grid is super high voltages, like 70 kilovolts, 115 kilovolts. So our tool has to maintain a correct visualization of the grid so that his engineers know the current state of the grid and don't do something that isn't actually, like basically if our tool shows something that isn't actually the current state of the grid, it has the potential to cause harm to Lefty or his team. So we need to make sure it can be kept up to date and has the correct circuit logic again. That's one of the most important things. And then the third thing, future-proofing. This is also really important, primarily because in the past 5 or so years, and then going up to like 10 years from now, Vandenberg is completely renovating their entire power grid. So it's going to be constantly changing. The tool has to be able to be modified and edited to be able to reflect the changes to the real power grid. So the main thing that we're doing to allow this future-proofing is to allow the grid to be easily editable by the user, which is also important because we're not making the real grid. So Lefty and his team has to be able to modify it to the real grid. But then also in the future, they have to modify it to reflect changes that are made in real life.
And that leads us to our engineering requirements, which we worked out using those customer requirements. So the grid needs to be interactive. It needs to have the correct circuit logic because of the safety required to keep everyone okay. The switching elements, we need to be able to open or close a switch. We need to be able to click a breaker to toggle it in or out to reflect what is actually in the world, right? If they remove a circuit breaker, they need the grid to reflect that. Additionally, the grid, it's very important that it shows how it's energized, which is just like we're going to use a highlight over the circuits in order to show the correct voltage running through that section of the grid at that time. The edit mode, as we talked about, is part of future-proofing, where we're going to create builder functions that will allow Lefty and his team to modify this mock-up into the actual grid for their use, as well as Andrew said, when they change the grid in the future, they'll be able to use this grid still. Abnormal visuals, that refers to when a switch is in its non-standard operating mode, it will have a different display as opposed to its normal display. So like if a switch is normally open, it will just be 2 parallel lines, but if it is then closed, we'll have an X through it that shows that it's closed, and the highlight will reflect that using correct circuit logic. And then zoom as well. So we wanted to be able to zoom and pan around the grid in order to see the different areas and move around. It needs to be interactive. So once we had our engineering requirements, we had to decide how we were going to make the grid. So we considered 4 different softwares. Those were Java 2D API, the processing software online, Visual Basic for applications, which is a Windows software, and P5.js, which is similar to processing. So we went through cost, features, the ease of use, as well as the portability, and we ended up deciding that processing was the one that we wanted to use. It had the most features that we wanted tied with P5, but all of these software were free, which was an early on consideration, as well as because on the base, the device that this will be used on doesn't have network connectivity. So These all need to be able to be moved onto the computer without the internet. And we found processing the easiest to use. So we chose processing. Moving on, looking towards the next quarter, these are our future steps, rough timeline. We plan to integrate mouse and clicking features as well as highlighting, very important for safety, the correct circuit logic so that when you click an element, the circuit reflects that, and then moving on, the builder functions so that Lefty's team can use it henceforth. This is us at the base. It's a good time. And any questions? No, that one's easy.
But you can see that thing there, the same as this.
Yeah, it's right there.
Keep it there.
So is this going to be like a single application on a single machine, or is it going to be like everyone is going to be able to see the same thing, and then if someone edited it, would like all be able to like see those changes?
It'll be located in one location. It'll be single machine, and it'll be updated, and then they'll have to reference that diagram.
So they have a big monitor in the scrum room where they have one computer designated for the application, so they'll be able to update it and like make changes. Be able to communicate.
And all these changes are going to be persistent to disk, right? It's not going to be stored in memory.
Yes.
If so, have you figured out a file format? Is it going to be editable so that they can edit it from the file, or are they going to interact directly with the UI and they'll update the file accordingly?
Right now, I'm storing all the components in a text file, and so it just has like the type of components and then 2 coordinates for where the component's at. And so, yeah, but we can still talk about more about like features like where we're going to store it.
For your edit mode or functions, builder functions is what I meant. I can see how that would allow the user to add existing components from the libraries, correct? And reroute the network. Would it also, how would you handle the ability to maybe add a completely different type of component that doesn't already exist?
Right. So I think we would have a set list of components.
Right. I don't know how to build in a new component, how to add in that features, but I know that Lefty's given us a list of what components he uses on the grid, like what type of things they have, and so we'll definitely be able to include that functionality for adding and removing those types of things.
There should be a finite list, I think.
Great, thanks guys.